Hello, my name is Alejandra Marquez and my research project is titled 3D Medical Image Segmentation using CNNs. First of all, we need to know what is segmentation. Segmentation is the process of finding objects within an image, but not necessarily understanding what these objects represent. An example of segmentation is shown on the left side, where each segmented part is represented with a different color. On the right side, we have a more specific type of segmentation called semantic segmentation. It is called semantic because each pixel is given a specific category. So, in the segmented image on the right, we know that the yellow pixels belong to a cat, the green ones to the grass, and so on. Now we will give a brief review of what a neural network does. It is a computational system that is able to learn based on example. It usually has two stages. The first is called training, and is shown on the left. Training is the same as teaching a neural network how to classify images based on their content. We do this by giving it two things. First, a bunch of images, as many as we can, and second, their corresponding category. In this example, we have images of 7 categories: airplane, bird, cat, and so on. The second stage is called testing and is shown on the right. In this example, we give the neural network the image that we want to know the category of. Based on what it learned on the training stage, it gives us class probabilities that represent how likely an image is to belong to a certain class. As we can see, the biggest likelihood is 80% probability of being a cat. Following the previous example of teaching a neural network how to figure out a label of an entire image, we can also teach it to segment. In this case, instead of teaching the neural network to assign a category to an entire image, we teach it to give a category for each pixel. We are classifying this with examples on the medical field. A 2D case is shown on the left, where we give the neural network the original image of a brain, and it outputs the different parts of the brain with different colors. A 3D example is shown on the right, and the difference is that it is a volumetrical image representing different cats obtained by a tomograph, and the result is the segmented organ in each of the different cats. Now, why do we use convolutional neural networks, also called CNNs? Because they are a special type of neural network for images. What makes them so special is that they can take advantage of the context and spatial location of each pixel. That's why they are good for semantic segmentation. Also, CNNs can learn different types of abstraction, different levels of abstraction from the data. In this example, we have 3 different levels of abstraction. In the first one, the CNN learns edges. In the second, it learns object parts. And in the third, it learns combination of edges, which are eyes, noses, etc. Finally, my proposal is to extend a method based on CNNs for semantic segmentation on 3-dimensional medical images. The typical pipeline for this task is as follows. First, we input a volume. Then we do some preprocessing for normalizing the images in terms of brightness and contrast. Then we do some data augmentation, which is useful for augmenting the number of training images, given that there aren't a lot of images in the medical field, and we need as much as we can for efficient training. Then all of these preprocessed images go into the 3D CNN architecture, and the neural network has to figure out how to output the given segmented volume. And as you can see, we also have another module called loss function. In this research, we are focusing on implementing a specific loss function, which is one of the most important components of the 3D CNN, and it is in charge of guiding training for better training segmentation results. Finally, we want to clarify that this work could have a good impact on the medical field in our country for the following reasons. First, medical images can vary from tens to hundreds of cats, and it is inefficient and tedious to manually analyze this data one by one in order to find anomalies or to analyze the different structures or organs contained in these images. So, CNNs could do that job for the doctors in an automatic manner. Also, using the resulting segmentation can help doctors recreating 3D models for easy exploration and manipulation of these images. For example, on the image on the right, where we can see a recreated 3D volume of the different parts of the brain already segmented. So this is my presentation, and thank you so much.